We're going to carry on looking at hydrographs today. So we'll start by thinking back to what we did last time. So you've got a hydrograph there in front of you. I want you to tell me, what is the peak rainfall, what time is the peak discharge, and what is the lag time in hours? So the answer to number one, the peak rainfall is 50 millimetres. So the rainfall is shown, or the precipitation is shown on these blue bars. The axis that you're looking at is the blue numbers. So you can see peak rainfall here, that highest blue bar go across 50 millimetres. What time is the peak discharge? The peak discharge is at roughly 11 a.m. So the discharge is this black line graph. The peak discharge is when it's at its highest point. So roughly halfway between 10 and 12. So I've just gone for 11 a.m. So what is the lag time in hours? It's 11 hours. So the peak rainfall was at 12. The peak discharge was at 11. So the difference in hours, 11 hours. So this lesson is all about evaluating the impact that different factors can actually have on hydrograph shape. So we're going to look at how the hydrograph can change, what factors can change it, why they can change it, and think about the impact that they can have. So we're over here. I'm going to do it's a bit of assess work today. I'll give you an exam question at the end. So this is a new term. It's called drainage density. And the drainage density is basically a way that we work out how many streams and rivers are actually in that drainage basin. So remember, your drainage basin is the whole area, the valley, I suppose, that all that rainfall flows into the river. You've got two drainage basins here, same size, but you can see that A has less streams than B. And the way we calculate that is we have the total length of all streams and we divide it by the area of the drainage basin. And that gives us a drainage density. The higher the number, the higher the drainage density. The lower the number, the lower the drainage density. So I've just put some made up numbers in here. So drainage basin A, let's say 5 kilometres of streams, divide that by the area, the size of the drainage basin, and I've put just 10. That gives us a value of 0.5, which means that's a low drainage density. Less streams in that drainage basin. You then look at B. Total length of all streams, I've just said 10 kilometres. The area, 10 kilometres. So 10 divided by 10 equals 1, means it's got a high drainage density. And that's important because if water flows in streams and rivers, it means it moves quicker. So an area with a high drainage density means water is moving through that drainage basin much more quickly than an area that has a low drainage density. So an area that has less streams. It means in this one, in A, most of that water is actually soaking in, it's infiltrating and moving through the soil and the ground, which is much slower. So it means it's less likely to cause a flood. So you can write down the definitions, write down the calculations. If you want to draw yourself some little diagrams, please do. So we're now going to think about what affects the shape of that hydrograph. So you've got two hydrographs here. Which one do you think is flashy, so responds quickly, and which one is a slow response? So the one on the left, that's your flashy. It responds very, very quickly. It has a steep rising limb, it has a high peak discharge, and it has a short lag time. Whereas this one on the right is your slow response. Rainfall's the same, not the bar chart's the same, but this river here has a much longer lag time, it has a much flatter rising limb, and it has a much lower peak discharge. So your flashy hydrograph, more likely to flood, your slow response, less likely to flood. And we're just going to go through some of the factors that can affect that. So you need to draw yourself a very simple diagram of each hydrograph, get the rough shape of the discharge to show that one is steeper than the other. You're then going to draw this table. So you've got 7 hydrograph characteristics, so characteristics that affect the shape of your hydrograph. And you're going to say what they are like for a flashy hydrograph, so one that has a short lag time and high peak discharge, and what it's like for a low flat hydrograph that is a slow response. So the first one, it's about basin size. So how would the basin size be different? Then you've got the drainage density, which we've just looked at. is going to be high or low. The rock type, so permeable or impermeable. Land use, relief. Relief basically means the shape of the land. Is it mountainous? Is it very steep? Or is it very flat? Soil moisture, so how much water in the soil. And finally, rainfall intensity. So once you've drawn your two little hydrographs and you've drawn that table, you need to look at the information on the next slide and put the correct statement in the correct box. So there's your table that you will have drawn. A low density leads to slower transfer. So you've got to think, well, which characteristics is that about? I think that's about drainage density. So a low density leads to slower transfer. Do I think that's going to be a flashy hydrograph or a slow response? I think that's slow response. So I'm going to write that statement in this section here. Then you've got high density speeds up water transfer. So that's still to do with drainage density, and that's going to cause a flashy hydrograph, so you'd write it there. You then read each statement and think which characteristic is it talking about and what type of hydrograph will it create. They are jumbled up, so they don't all match. They're not in the correct side or in the correct order. So you've got to work that out. Once you've done that, press play and I'll give you the answers. So basin size, small for a flashy hydrograph, large for a slow response hydrograph. That's because smaller basins, it means the rainfall can get into the river more quickly. Okay, so next one, drainage density. Well, it's going to be high density for your flashy, low density, slow transfer. Remember, high density, more water on the surface, quicker. Rock type, impermeable, rapid overland flow. Impermeable means water can't soak in. Permeable for your slow response. That means water can soak in, it can infiltrate. Land use, urbanisation, so putting down concrete, building things, that causes rapid transfer. Whereas if you've got lots of forests, that slows it down because the trees catch it, cause interception, store it. Steep slopes, flashy hydrograph, because water flows across the surface rather than soaking in. If it's gentle slopes or flat, water infiltrates, it soaks in. Soil moisture, if soils are saturated, so full up, water flows across the surface. If they are dry, they can soak up water like a sponge. That water can infiltrate and not end up in the river. Rainfall intensity, so heavy rain means that water can't soak in, it's going to flow across the surface. And light rain means water is more likely to soak in, more likely to infiltrate and move more slowly to the river. So what you'll notice is your flashy hydrograph is when water moves quickly across the surface, gets into that river quickly, causes the amount of water to increase, causes the flood. Whereas anything that slows down the movement of water, causes infiltration, stops water getting into the river, makes it less likely to flood. So make sure you've got those written in the correct column and in the correct characteristic. We're now going to apply that to an exam question. So explain how two physical factors other than land use may increase the risk of flooding. So before you attempt this, it might be worthwhile going back to your table and colour coding. So in one colour, green perhaps, colour in the physical factors, so the natural things, the things that happen naturally. And in another colour, maybe like a red or something, highlight the human factors, so things caused by people, what people have done. Once you've highlighted them, you can then pull out two physical factors. You then need to say how they increase the risk of flooding. So you can't talk about land use. Two physical factors other than land use and how they may increase the risk of flooding. So name one physical factor, that's your point. You then develop it. So you say this means that leading to, as a result, because. Say how that physical factor may increase the risk of flooding. You then repeat that for another point, another physical factor, and develop it. I'd like to submit your exam question. I'll show you my homework, I'll mark it, I'll give you some feedback, and then I'll give you a model answer to approve it with next lesson. Okay, lovely. Take care. See you soon. Bye-bye.